Okay guys, so this is the first section of my short series of help videos on preparation for the UCAT, and I'm going to start with abstract reasoning. Not the most popular section of the UCAT. You're under a lot of time pressure when you're doing abstract reasoning. So you've basically, in the abstract reasoning section, thinking about timing, you've got to complete 55 items. Now, an item can be allocating 5 different shapes into the right set. So it isn't 55 entirely separate questions, but it is 55 items in 13 minutes. It's a very time-pressured section, so you need lots and lots of strategies in order to try and maximise the number of points you score in this type of section. So you've got 50 items from type 1 and 4 and 5 items of types 2 and 3. So when you get to a type 4 exercise, which is the ones we start with a type 1 exercise. If you start with a type 1 exercise, you're looking to spend roughly a minute on a type 1 exercise. And that's allocating all the shapes within that. Similarly, with a type 4 exercise, you're looking to spend about a minute. And with a type 2 and 3 exercise, about 30 seconds each. So the full exercise for type 1, for each exercise, you want about a minute. For type 2 and 3, about half a minute for your timing. But if you spend too much time thinking about timing, as we know, timing takes time. So you've got to kind of, I feel, like get a gut feel for the time, as opposed to being too obsessed with following the time on a watch or on the screen. You've got to get a kind of feel for how fast you're going through these things. So that's a bit on the timing really for the abstract reasoning section. The next thing to think about is why you might need to do abstract reasoning at all. So what purpose is this part of the test demonstrating? And it's actually showing you a way of discriminating items. And I can't even spell today. Let's try again. I think I was writing distraction. So it's a way of discriminating useful information from irrelevant information for a start. So some information you're given as part of these exercises is useful. Some of the shapes and patterns are irrelevant. So you've got to be able to pick out useful information from information that has no bearing on the solution to the problem. That's quite useful for a doctor. So for example, if a patient presents at the hospital and you take a case history, some of what the patient says is going to be useful and some of it is going to be irrelevant. Because the patient doesn't know what's wrong with them, they can't only give you useful information. They're going to give you everything that they know and everything that they think is important to tell you. The other thing is you might have to be able to connect pieces of useful information together. So let's say your patient who's giving you all of this information, some of it is relevant, some of it is irrelevant. But in amongst all of that, they give you 2 pieces of information that help you to go on to make a diagnosis, because those 2 things coinciding are really important. It might also be that some of the things that coincide point to 2 different problems within the same patient, something that we call a comorbidity. So it's important that we have this idea of picking out what's relevant and what isn't relevant, connecting pieces of useful information together, and finding out whether something is working together to give a diagnosis or in parallel, meaning that the patient may have actually two different things wrong with them. So that is the purpose of the abstract reasoning. And because you don't know at this stage in your medical careers, you don't know any information to do with diagnoses at all, they can't ask you to take a patient history and to use that patient history to come up with a diagnosis. So they have to give you these questions in a form that is completely abstract. It means that you don't need any prior knowledge to be able to show your skills in doing these things. And that's where the concept of abstract reasoning comes from. So instead of asking you these questions in an actual medical scenario, they see how you can discriminate using things that you are familiar with, and shapes, angles, patterns that you can actually relate to and demonstrate these skills using. So that's the purpose of abstract reasoning. It's one of the highest order skills within the UCAT, which is why I thought it would be a good idea to do this one first. The next thing to talk about when we're thinking about doing the abstract reasoning is, as I've mentioned, they can't have you doing it with actual patients and actual medical conditions because you don't know any of that yet. But what they can ask you to do is to think about shapes. So we're going to start, before we actually go on to looking at any questions at all, we're going to think about shapes. So we're going to go back to some basics really of shapes, features of shapes. I'm just drawing a few shapes here. Now, when you're practicing, to do abstract reasoning, you want to be able to quickly recognise some of the most common shapes that you're going to encounter and some of the less common shapes that you're going to encounter, such as the one I'm drawing at the moment, and know instantly how many sides it's got, what its main angles are. So for example, a square, that's going to be very easy for you to say immediately that's got 4 sides. But perhaps that diagram that I drew last, so this one I'm circling now, that's harder. So if you make sure that you have memorized the number of sides in this particular diagram, that's going to save time. So this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. But if you can remember that when you encounter this shape, which does sometimes come up in UCAT, okay, that's got 12 sides. That will speed you up. Recognise octagons, recognise pentagons, and immediately, instantly know how many sides they've got. Objects such as this object here, okay, so it's got 4 sides. Admittedly, one of them is curved, but just know instantly how many sides something has is really, really helpful at speeding you up. Because one of your strategies is going to be, does this have an even number of sides? Do the number of sides correlate with the number of objects? That kind of thing. So if you can instantly, by looking at your objects, quickly tot up even versus odd numbers of sides, does that correlate with anything else? That's quite helpful. So what other features of objects that you might encounter might be the angles, particularly right angles, are quite useful. So you might see that the number of objects in the box correlates to the number of right angles or the number of non-right angles. Okay, so recognising right angles versus non-right angles is useful. Having curved edges might be important versus having straight edges. So this shape has only straight edges. So this triangle only straight edges, whereas this crescent moon has curved edges. You might get shapes with points of inflection that look a bit like flags. So you might get 2 curved edges. You might want to think about the planes of symmetry that the object has. Okay, so you can have objects with multiple planes of symmetry. Like I'm drawing here, loads of planes of symmetry. That's a completely symmetrical object. So you could draw planes of symmetry in all directions through that. But if you were to take the crescent moon, for example, the crescent moon has only got that one plane of symmetry. So that might be important. So thinking about that kind of thing. Three-sided shapes. Okay, so have you got an even or an odd number of sides? So two odd numbered, so two shapes with 1, 3, 5, 7, etc. shapes sides becomes even when there's two of them. So if in my box I've got two three-sided objects, that's even. So you can immediately tot up the number of odd-sided objects to see if overall you've got an even number of sides in there or an odd number of sides in there. Remember, a circle is one side. Sometimes it might be important whether the circle is coloured in or the object that you're talking about is coloured in or not. Sometimes it might be important if the objects are intersecting. So what we mean by intersecting is if an object overlaps like this. And does it matter whether one object is on top of another? So obviously in the diagram I just drew there, you can't tell which is on top, but they might draw it in such a way as that one object is on top of another object. That might be important. And which object is on top? In this case, the triangle's on top. Is that important that the triangle is on top? The position in the box can be important. So if I'm imagining this is the box, maybe there's always a circle in the top left hand corner. That means that even once you've worked out what the pattern is, if the boxes underneath don't have a circle in the top left hand corner, they can't be part of set A, for example. So there might be an object in the top corner. There might be a sequence, so things might be moving around. So for example, you might have a segment like this, where things are moving around the different quarters of the segment, and that might be important. So for example, the number of dots might correlate to the segment that it's in, for example, like so. What else might be important? Objects being different sizes. So you might have big circles versus small circles. Could there be a key object? So a key object is one that you've identified appears in everything. And often when that happens, it's either there because it's really important or because it's a distractor. So being able to discriminate, that's where I mentioned about at the start, I mentioned information that is relevant against information that is irrelevant. So we might have distractors in there, things which are designed to look important but which aren't actually important at all. They just happen to be there all the time, but they're not actually important. So that's a kind of introduction really to the different types of things which might be important. So I'm just going to recap on the things to bear in mind to have in your list of things to go through. And remember, you don't have a great deal of time. So you've got to get these really, really well practiced. So the first thing to think about is the type of objects. What have you got in those boxes? Have you got a mixture of shapes, sizes? Do you have the same object in every box? Is there a key object? Okay. The next thing to think about is the number of objects. This often relates to something. Does it match with the angles that there are in there? Does it match the number of objects that have a right angle, for example? So is the total number of shapes equal to the number of right angles in the box or equal to the number of non-right angles in the box? So does the number of objects matter? The number of objects of itself might matter. The number of sides on the object might matter. So that's the next one to mention. So the number of objects is important, the number of sides. is most definitely important. And like I mentioned right at the start, be able to quickly recognise some of the key shapes, the number of sides they have, without having to start counting them. Because if you have to start counting sides, you're going to run out of time. You need to know all those shapes off by heart. So yeah, sides are very important. Symmetry. So does the object have a plane of symmetry? And I'm going to add rotation to that. Okay, sometimes rotation is really important as well. So symmetry and rotation and mirror image can all be really important. As well as sides, we've got angles, both number of angles. So the number of internal angles, for example, in different shaped objects can be important, as can the type of angle. So is it a right angle? Is it an acute angle? Is it an obtuse angle? E.g. right angle. Okay, so we also mentioned shapes intersecting with each other. Okay, so when those objects are cutting over each other and having objects on top of one another. That's really important. Then I think I've mentioned everything. Shapes, sizes, same objects, key objects, number of sides, symmetry, rotation and mirror image. How about whether the colour, so is it's going to be a black and white test, so it's only going to be a black and white object. So for example, it might be that colour links with the number of sides. So for example, all four-sided objects might be black, or all objects with right angles might be black. So it might be a particular feature of an object that means that it is coloured in black. Sometimes we might have arrows, clocks, dominoes, that kind of thing. These come in like an odd section of, like, if you've got arrows, which way do they point is always important. If you've got clocks, okay, so what's always going to be important is going to be where the hands are pointing, obviously. Where are the hands pointing? And you can always try multiplying the two numbers that they're pointing at as a useful first, or subtracting, or doing things with the numbers that they're pointing at, but multiplying them off is often a really good place to start when you've got clocks. Dominoes, okay, so which dominoes add up to the most? Black and white dominoes could be odd or even. Versus even. There could be it could be the positioning of the black and the white domino might signify which is bigger than the other. And then obviously remember, for all of these things, set A is going to mirror set B. So usually, if you can work out what the pattern is for one of the two sets, then set B will mirror, this is for type 1 and type 4, obviously set A is going to mirror set B. So I think that probably just about sums up the things that you've got to be watching out for. Now, if you think about it, if I spent time looking for all 8 of those things and all of the subsections of different things within those 8 systematically, and I've got a minute to do that, that's This is going to be a very time pressured section, no matter how good you get at it, but you're going to have to do quite a lot of practice. So these are ones where you can definitely train yourself to get better, and you will definitely more quickly get to ruling out or including potential relationships depending on the type of thing that you see. So for example, you get dominoes, you've got your domino strategy, you've got intersecting objects, you've got different sets of sides. You're going to have your strategy once you've done enough of them to be able to work out the best way of going for each one. So I think it's probably worth having a look now at some of the some practice ones. So for this, I've used one of the UCAT books to give me some examples to actually work on. You might have done some of these already, but I'm going to try and talk you through how I approach these questions. So even if you have done some of these questions before, I think possibly just thinking about how you've done them and how you might have approached them might be helpful, and whether or not any of the strategies that I go through might help you to speed up. Okay, so if I just save that, I can then come to some practice questions. So starting at the first one here, I'm hoping my pen is going to work. I'll use my red pen. Okay, so in this first one, this is I'm going to talk through what the actual exercise, what you actually have to do in an exercise like this. So you've got two sets of objects, and you've got to decide what the rules for each set of objects are. You've then, once you've decided on what the rules are, you've got to then decide whether the shapes underneath fit within set A, set B, or neither of the two sets. Okay, so when we're looking at one like this, the first thing I would do is look to see if there's something consistent. Always look to see if there's something consistent in all of them. The black dot looks promising, but it's not in this one or this one. There isn't a black object in all of them. I've got a mixture of circles, pentagons, triangles. So edges could be important here, because all of these things I can quite quickly count up the edges. Looking quickly into set B, again, there doesn't look to be any kind of consistent pattern here. They all look as if they've got a complete mixture of objects. So it would appear that the different colours are just distractors. So I'm going to do sides now. Okay, so I've got a pentagon. 5 plus 3 is 8, 9, 10, 11, 12, 13 in that one. 5, 5, 10, 11, 12, 13. This is looking promising. 5, 5, 11, 12, 13. I don't really need to go on too much more. I haven't got time to necessarily check every single one. So at this point, I think sides adding up to 13 is important to be part of set A. So I'm going to move on to set B, because if that is the case, set B will be mirrored and there'll be the same number of edges in each of these. If it isn't, I might as well forget counting sides, because it's not the right thing. So looking in set B, 4 plus 3, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. Right, okay, I've done enough now to have worked out what it is. I don't need to confirm it in every box. I've got 13 versus 9. Now, I might hear you saying, well, how can you be 100% sure? I can't, but I've got a minute. So I'm going to have to say there's 13 sides to be part of set A. There's 9 sides to be part of set B. And I'm going to move on to allocating my shapes, because once I get to allocating my shapes, I'm actually getting points. I haven't got any points for determining the pattern. I'm only going to get the points when I complete the answers. So I'm going to have to quickly go from allocating how many things, what's important, to actually determining. So 5, 9, 10. So the first one is in neither. So that's this one here. The second one, okay, that's immediate. I can see that's 13. 13 is set A. The next one is neither, because it's got 14 edges. Again, that's a quite instant one. This is what I mean about making sure you learn your shapes beforehand, so you're not actually counting edges. Pentagon, pentagon, square adds up to 14. So that's neither. And then I've got, this is 13, because I've got 4 triangles and a circle. So that's set A. And then I've got 6, 7, so that's neither. And that's the first question done. Now, it's taken me longer than a minute because I've talked through it, but hopefully you can see roughly how we've gone about doing a question such as that. So what I want you to do now is I'm going to time a minute, and I just want you to see with this second exercise whether in 1 minute you can work out what the pattern is. So this is slightly longer than you're going to get, because in 1 minute you'd be expecting to allocate some of the bottom as well. So I'm just going to put my watch on to time in a minute. You're getting a bit of extra time to look at it now as well, which is quite good. So let's see in 1 minute, starting now, how far you can get. Okay, so that's 1 minute, and I bet that didn't feel very long. And I bet I'd be surprised if you've got to the relationship in that period of time, unless you've already been doing quite a lot of practice on these. So let's have a look at them and see if I agree with what you think the relationship might be. My first glance at these, I can see that there is a circle in every single one. So it could be important, but I'm already going to be able to rule out, I think, that there's got to be a circle in every single one for it to be part of A or B. So I can already allocate that shape 2.1 is neither, and then so is 2.4, and so is 2.5, because there isn't a circle, and there is a circle in everything else. So that's a handy one to be able to do. So I'm actually only telling the difference between shapes 2.2 and 2.3 as being potential candidates. Now, I would hazard a guess, even before looking and seeing if I can identify a pattern, I would hazard a guess that shape 2.2, looking at it, it's got a circle, it's got one of these kind of half cylinder type objects in there that I can see happening quite a bit up here, and it's also got a triangle which is pretty much identical to the bottom right hand one, so that's got to be set B. Now set A, the question is, does 2.3 fit within set A? Now I can also see set A has got triangles in all of them except one, but this one does have another object in it which might be important. So I need to think a little bit more about what the pattern in set A might be to be 100% sure. Let me just get my, I was just going to rub that out so you can see a little bit more of what's happening back in set A. We've got the circle, but in addition to that, we've got something with straight edges in all of them. This one is a problem because it doesn't seem to have So I'm saying 2.3 is a problem because it doesn't seem to have like a square or a pentagon or a triangle, something with straight edges. So that is neither, in my opinion. Okay. So that's the way I've gone about doing that one. I didn't spend too long thinking about what the rule is, but I've worked it out as I've gone along. So how I'm going to articulate the rule to you now is that by a process of elimination, I think, more than anything, all of them from set A and set B have to have a circle. In set A, you have to have a circle and a straight-sided object. And in set B, you have to have a circle, a curved-sided object, and another object of some description. So this has got a circle and an object with curved edges. I'm just going to highlight the curved edges there to show you what I mean. A circle and an object with a curved edge. Okay. Oh, and I've just noticed as well that set B, as well as having an object with a curved edge, seems to always need a straight-edged object as well, because they're all straight-edged, aren't they? Okay, so that's the actual rule. So we've got the circle, the circle, the circle, the circle, the circle, and the circle, and at least one straight-edged object, but no curved-edged objects. Okay, so that's that one. So hopefully you can see what we mean by how we go about doing these and also what we mean by going fast. So see how you get on with the next one, practice 3. Okay, so again I'm going to time a minute and you can see how far you've got to. Now if you want longer than a minute for now, if you, let's say you want 5 minutes before I come in with explaining the answer, just pause the video for slightly longer. But I'm going to time a minute for each one, so that's going to start now. And stop. Okay, I wonder how far you managed to get in that minute. So let's have a look at this together. This is an arrow one, so the directions of the arrows are going to be what's important. And it's one of those questions, I think, where you might just get it instantly. Because as you're looking at these arrows, you might notice in set A straight away, there's nothing pointing right. For me, this is quite a quickie. I don't know about anybody else, but for me, the fact there was nothing pointing right was really quite immediately obvious. So the first thing I was looking for then was whether or not there was something pointing left in set B, because my sets are usually going to mirror each other. But I can't see anything pointing left in set B. So this one is actually quite a quick one. To be able to allocate my shapes, I need to look at the other arrows, and I've also observed that set A has everything but right, set B has everything but left. So the first one, shape 3.1, well, that one can't be any of them because there aren't any down or left arrows, so that's got to be neither. The second one doesn't have any right arrows, but it has everything else, so that's set A. The one after has up, down and left, so that's also set A. The next one has up, down, left and right. So that one can't be in either of them. And then the last one is up, down and right. So that must be set B. So I think that was probably one of the easier ones that you might encounter. I sometimes love it when they've got the arrows. I think arrows can be quite a lot easier than the more abstract ones, including shapes, sides and angles and that kind of thing. So I hope you managed okay with that one too. We're going to have a go at practice number 4. I'm going to time your minute, but obviously if you want longer, you can pause the video and have as long as you like before we go through the solution. Time starting now. And stop. So nice big objects now. So we're not talking numbers of objects, probably not sides, because the number of sides on both set A and set B are very diverse. So it's probably nothing to do with sides. I'm looking for big objects. I'm looking for symmetry. And hopefully once I've mentioned symmetry to you, that might actually trigger, oh yes, I know what you mean now, I can do it. So if symmetry has helped you to think you might be able to crack this, you can pause the video again and have another go. Okay, for those of you who have already got the idea of symmetry, then for me these objects are quite straightforward, because to get back to the same shape I've got to rotate these shapes through 180 degrees to arrive back at the same shape. So if I went 90 degrees with this one, it would go up to here. So I've got to go all the way to 180 to get back to the same shape that I had before. With these ones, I've only got to go 90 degrees before I arrive at exactly the same shape as I had before. So hopefully that makes sense when I draw those angles on. See this one, obviously if we went through 90 degrees it would be coming out horizontally. It's got to go all the way around. Similarly with this oval, okay, it's got to go all the way around before it's going to look the same again. So having a look at the examples then now, I'm going to give you, now you know the answer, I'm just going to give you another 30 seconds to see if you can allocate each of these objects. And stop. Now I just want to, before I allocate these objects myself, I just want to say that determining what the relationship is, although that's probably the hardest bit, I've just got to remind you it gets no marks. You only get the marks for allocating the shapes at the bottom into the correct set. So that is such a vitally important thing to do. You've got to give that the right amount of time. The temptation to spend a long time allocating, which you have to do to work out what the set might be, but then if you rush doing the allocation at the end, that's the only place you get the marks. You don't actually get any credit for working out what the pattern is. So really think very carefully about these and spend a little bit of time if you need to make sure that you allocate the shapes correctly, because that's the only place you get any marks for doing these exercises. If you have no idea whatsoever, look at the two sets more from a distance, sort of don't scrutinise, just like look back and then just guess which they look more like. And your brain will do a lot of hard work for you if you have absolutely no idea. It's not negatively marked on the UCAT, so if you have given it some time to work out what it might be, you have absolutely no idea, take that kind of overview look and just guess, does it look more like set A or does it look more like set B? Or does it look completely like neither of them at all? So looking at these ones, we have worked out what our pattern is, so it should be fairly easy to say that the moon would have to go through a full rotation before it looked the same again, whereas this tablet shaped object is definitely set A. Now set B, this one's a cruel one actually, because if they hadn't put that little line on there, it would have been a set B. But by putting that little line on, if we only went through 90 degrees, the line would be sticking up. So that one actually makes this one a set A, one that's got to go through 180 degrees. The star is, you'd have to go to look the same. You're not going to go through 90 degrees, you've got to go through a smaller angle. You've got to go through a fifth of a turn rather than a quarter of a turn. So that one is neither. That's a bit of a cruel one. And then the last one, again, that's quite an obvious one, an arrow pointing one way needs to go through 360 to point the same way again. So that must be neither. It can't be. It would point the other way if you just went through a half turn. Okay, so a few more tips as we've gone through exercise number 4. So if you want to pause the video, take a break, have a little walk around the room, look out of the window, refocus your eyes on something that isn't a puzzle for 10 seconds, because when we come back, you're going to be having a look at exercise number 5. Okay, so your minute for exercise number 5 is starting now. And stop. You can obviously extend, you can extend this if you want to have a little bit longer. Now, this one had me flummoxed for about 30 seconds, and then I did that thing that I said to you guys to do, which is just to look back and look at just the whole thing and see if you can see a pattern. And that's when it jumped out at me that on the left hand side I've got everything has a circle, but on the left hand side I've got small black objects and big grey objects, and on the right hand side I've got big black objects and small grey objects. So for me, set A is a circle with small black objects that are smaller than the grey objects, and then set B on the right hand side has small grey objects and big black objects. Okay, so let me have a look now. I'm going to give you 30 seconds. I wonder if you came up with the same solution as I did. I hope my solution is right. If you want to have a few moments now, I'll do 30 seconds to allocate your objects. Okay, now I don't know whether, like me, when you started to allocate the objects, you realised there was slightly more to it than just the objects being big and the objects being small. I think it actually goes further than that. I think it goes to whether or not the objects will indeed fit inside the circle that is crucially important as well. So in the first shape, 5.1, none of those objects, well, the little black circle would do, but the other two objects, the black rectangle and the grey triangle, none of those objects will fit in the circle, even though that black square on the left would. So that is neither, because it's neither the grey nor the black that will exclusively fit inside the circle. Looking at the next one, so this shape has got a big grey triangle and a small grey triangle and a black rectangle. Now the big grey triangle isn't going to fit in the circle, but the black rectangle will fit inside the circle. So that means this must be part of set A, because that's what the rule is for set A. I think if we look at this one now, even though they've put the two black objects inside the disc, it's actually the grey objects that are going to fit inside the circle. And so this one is now set B, which is the one where the grey objects are small. And then the next one, all the objects are small, so that must be neither. Likewise with the last one, all of the objects are small, so that one can be neither either. Okay, so that's my bet for those ones. So back to practice, the practice next question, and you've got a minute for number 6, starting now. And stop, and carry on if you've got if you've paused your video for a couple of minutes. This one's mean. I think I might just about have it. I wonder what you've come up with. The best I can come up with at the moment is that there doesn't seem to be a pattern. There doesn't seem to be a pattern that relies on the inner circles being different from the outer circles is what I'm trying to say. So if I was to say like the grey bits, if I highlighted all the grey bits, there's one grey bit, 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 and one grey bit. So there's no coincidence there that there's one grey bit. I'm just going to use a different colour just to see whether my strategy... I know you can't use highlight them in colours when you're doing your UCAT, but this is one of those